Route surveys are surveys made for the purpose of locating any building, highways, canals, power transmission lines, pipelines, railways, rapid transit, and other utilities, which are constructed for purpose of transportation or communication. Surveys are required for all types of route alignment, planning, design, and construction work. The first topic in route surveying is simple curve. So what is simple curve? A simple curve is a circular curve used to connect two tangents intersecting at a point. Sample number 1. Two tangent of simple curve have azimuth of 237 degrees 10 minutes and 270 degrees and 15 minutes are connected by a 3.3 degrees curve. If station V is at 6 plus 156.15, compute the other elements of the curve. First, solve the angle of intersection or I by subtracting the given azimuth of two tangents. So I is equals to 273 degrees 15 minutes minus 237 degrees 10 minutes, and the angle of intersection is 36 degrees 5 minutes. The second element is arc basis. R equals to 20 times 360 degrees over 2 pi d. So R equals to 20 times 360 over 2 pi. The degree of curve is 3.3 is equals to 347.247 meter. The next element is the tangent distance. So T is equals to R, tangent I over 2. So T equals to 347.247 tangent 36 degrees 5 minutes over 2. So the tangent distance is 113.106 meter. The next element is length of curve or L sub C. The formula is L sub C is equals to 20 times I over d or the degree of curve. So LC is equals to 20 times 36 degrees 5 minutes over 3.3. The answer is 218.67 meter. Next is the long chord or LC. The formula is LC is equals to 2R sine I over 2. So LC equals to 2 times 347.247 sine 36 degrees 5 minutes over 2. So the answer is 215.09. Next is E or the external distance. The formula is E equals to R times secant I over 2 minus 1. So E equals to 347.247 secant 36 degrees 5 minutes over 2 minus 1. The external distance is 17.956 meter. So M equals to R times 1 minus cosine I over 2. M is equals to 347.247 times 1 minus cosine 36 degrees 5 minutes over 2. So, the answer is 17.07 meter. The last element is the station at PC, wherein station PC is equals to station V minus the tangent distance. So station PC is equals to 6 plus 156.15 minus 113.106, or station PC is equals to 6,000 plus 156.15 minus 113.106. So the answer is 6,043.044, or the station PC is equals to 6 plus 43.044. Problem number 2. The long chord and tangent distance of a circular curve are 90 meter and 65.30 meter respectively. If station PC is equals to 4 plus 210, determine station V and station PT. Solution. Station PC is equals to station V minus the tangent distance. 4 plus 120 is equals to station V minus 65.30. So station B is equals to 4 plus 275.3. Station PT is equals to station PC plus L sub C, where L sub C is equals to 20 I over D and T is equals to R tan I over 2, where the tangent distance is equals to 65.30 equals to R tan I over 2, and R is equals to 65.30 over tangent I over 2. Equation 1. The next topic in route surveying is compound curve. A compound curve is a horizontal curve composed of two or more circular arcs of radii tangent to each other with their centers on the same side of the common tangent. Sample problem. The long chord of a compound curve is 475 meter long, and the angles that it makes with the tangent of the curve are 24 degrees and 28 degrees respectively. Find the R1 and R2 of the compound curve if the common tangent is parallel to the long chord. Delta PC minus PCC minus PT. Theta is equals to 180 minus 12 degrees minus 14 degrees. The answer is 154 degrees. By sine law, LC1 over sine 14 degrees is equals to 475 over sine 154 degrees is equals to LC2 over sine 12 degrees. The answer of LC1 is equals to 262.136 meter, and the LC2 is equals to 225.284 meter. LC1 is equals to 2R1 sine I over 2. So LC is equals to 262.136 is equals to 2R1 sine 240 over 2. So R1 equals to 630.40 meter. LC2 is equals to 2R2 sine I over 2. So LC2 is equals to 225.284 is equals to 2R2 sine 28 over 2. So R2 is equals to 465.61 meter. The next topic in route surveying is reverse curve. A reverse curve is a curve formed by two circular simple curves having a common tangent but lies on opposite side. Example number 1. The common tangent BC of a reverse curve is 170.3 meter and has bearing of south 37 degrees 50 minutes east. AB is the tangent of the first curve whose bearing is north 65 degrees 35 minutes east. CD is the tangent of the second curve whose bearing is north 29 degrees 43 minutes is A is the PC while D is the PT. The radius of the first curve is 120 meter and PI is at station 10 plus 418.46. Determine the stationing of the PT. Solution. T1 is equals to R1 tangent I over 2. I1 is equals to 180 degrees 265 minutes 35 seconds minus 37 degrees 15 minutes. Answer is 77 degrees 10 minutes. So T1 is equals to 120 tangent 77 degrees 10 minutes over 2. T1 is equals to 95.738. So T1 is equals to 95.738. L sub C is equals to 20 I1 over D1 is equals to 20 I1 over 20 times 360 over 2 pi R1 is equals to pi R1 I1 over 180. L sub C is equals to pi times 120 times 77 degrees 10 minutes over 180 degrees. LC is equals to pi R2 I2 over 180. So I2 is equals to 180 degrees minus 29 degrees 43 minutes minus 37 degrees 15 minutes. So I2 is equals to 113 degrees 2 minutes. And BC is equals to 170.3 meter. T1 is equals to T2 is equals to 170.3 meter. 95.738 plus R2 tan 113 degrees 2 minutes over 2 is equals to 170.3. So R2 equals to 49.320. So L sub C is equals to pi times 49.320 times 113 degrees 2 minutes over 180. L sub C is equals to 97.299 meter. The next topic in route surveying is vertical curves or parabolic curves. In highway curves, abrupt change in the vertical direction of moving vehicles should be avoided. In order to provide gradual change in its vertical direction, a vertical parabolic curve is subducted in account of its slope, which varies at constant rate with respect to horizontal distances. Sample problem. A 300 meter symmetrical parabolic curve has a grade of -5% and 7%. Station PI is at 6 plus 600 with elevation of 115.25 meter. Find the elevation at the top culvert placed at the lowest point if the backfill depth is 0.8 meter. Given G1 is equals to -5%, G2 equals 7%, station PI equals to 6 plus 600, elevation PI is equals to 115.25 meter. Elevation at the lowest point is equals to elevation V plus A plus Y. Elevation in top of culvert is equals to elevation of lowest point minus OG. Elevation PC is equals to 115.25 plus 0.05 times 100. Elevation PT is equals to 110 plus 0.07 times 100. Earthworks. The excavation, removal, and dumping of earth is a frequent operation in building or civil engineering works. In the construction of a sewer, for example, a trench of sufficient width is excavated to a given depth and gradient, the earth being stored in some convenient place, usually the side of the trench, and then returned to the trench. Sample problems. Given the cross-section nodes of an earthwork between 5 plus 000 and 5 plus 075, assume width of the road is equals to 10 meter. Station 5 plus 000 left 7.1 over 1.4, at the center 0 over 1.8, at the right 8.45 over 2.3. Next station is 5 plus 0.75, left 8.0 over 2.0, at the center is 0 over 1.2, and the right is 7.75 over 1.5. Compute the volume between the two stations using an area method, prismoidal formula, prismoidal correction. First, an area method. Solution. The formula is area equals to W over 4 times H1 plus H2 plus H2 over 2 times W1 plus W2. To get the area 1 is equals to 10 over 4 times 1.4 plus 2.3 plus 1.8 over 2 times 7 plus 8.45. The answer is 23.25 meters square. And area 2 is equals to 10 over 4 times 2 plus 1.5 plus 1.2 over 2 times 8 plus 7.75. The answer is 18.2 meters square. The volume of an area method formula is equals to area 1 plus area 2 over 2 times the length. So V is equals to 23.25 meters square plus 18.2 meters square over 2 times 75. So the area method is equals to 1554.38 meters square. Next is prismoidal formula. The formula of area middle is equals to W over 4 times H1 plus H2 plus HC over 2 times W1 plus W2. The volume of prismoidal is equals to length over 6 times area 1 plus 4 times area middle plus area 2. VP, or the volume of prismoidal, is equals to 75 over 6 times 23.25 meters square plus 20.74 plus 18.2. The answer is 1555.125 meters square. Next is prismoidal correction. The formula of prismoidal correction is equals to length over 12 times C1 minus C2 times D1 minus D2. And C1 is equals to 1.8, C2 equals to 1.2, D1 is equals to 15.55, and D2 is equals to 15.75. The volume of prosmoidal correction is equals to 75 over 12 times 1.8 minus 1.2 times 15.55 minus 15.75. The answer is 0.75 meters square. Volume correction is equals to VE minus VCP. So volume of correction is equals to 1554.188 minus negative 0.75. The volume of prosmoidal correction is equals to 1554.938 meters square.